Part 2 of Lesson 3.3, Properties of Logarithms. We're going to be expanding and condensing expressions using the three properties. So example 3 says expand this expression. This is a common log, and when I say that it's a common log, it's because the base is 10, even though you don't see a base 10 right there. 10 is assumed to be there. So the first thing I would do is I would rewrite it as the log of 12 plus the log of x to the fifth plus the log of y to the negative 2. Each of these are common logs. There's no base written. That's our product property, which says if you've got multiple values inside of a log that are being multiplied, you can separate it and write it as addition. And then the next property that I use, I don't do anything with the log of 12, but the next term I can change into 5 times the log of x. That's the power property, where you take the exponent 5 and you make it a leading coefficient. We do the same thing on this last term to get negative 2 log of y, and that is as expanded as possible. Part B, same kind of problem, except for this time we have a natural log instead of a common log. And now we've got two terms being divided, so we'll have to rewrite this as the difference of two logs. Okay. Then on this first term, we can take that exponent and make it a coefficient, so we change it into 2 natural log of x. The next thing I'm going to do is I'm going to rewrite this expression as 4x plus 1 to the 1/2 power. Anything inside of a square root is the same thing as being raised to the 1/2 power. Now we can move that 1/2 out in front, so we get 2 natural log of x minus 1/2 natural log of 4x plus 1. And that is as expanded as possible. Example 3, more of the same. This is a log of base 13. We're going to rewrite it as the sum of log of 6 base 13 plus log of a cubed base 13 plus log of b base 13 plus log of c to the 4th base 13. Now we just take the exponents, make them coefficients to get our final answer. So 3 log of a base 13. This stays the log of b base 13, and then this becomes 4 log of c base 13. And then part B, same kind of problem. This time we have natural logs. So we're going to rewrite this as the natural log of 3y plus 2, and then minus the natural log of 4 times. I'm going to rewrite that third root of y as y to the 1/3. And now in seeing this, got some more work to do. We got the natural log of 3y plus 2. That's going to stay. But now you see that we've got 4 times y to the 1/3. But both of those are inside of a natural log that's being subtracted. So what I'm going to do is I'm going to use brackets here. And then I'm going to rewrite this as the natural log of 4 plus natural log of y to the 1/3. So what's going to end up happening here is this negative sign is going to need to be distributed to both of those terms. Natural log of 3y plus 2 minus natural log of 4 minus 1/3 natural log of y is our solution. So one way of looking at this, you guys, is since the 4 and the y to the 1/3 were in the bottom of the fraction, both of those need to have minus signs in front of their logarithms. So that's expanding. Now we'll also have problems where they ask us to condense. We have to take this expression and condense it down. We're just going the opposite direction. So my first step would be to take the 4 log of x base 3 and change it into log of x to the 4th base 3. In the same way, we're going to change the 1/3 log of x plus 6 base 3 into the log of 3rd root of x plus 6 base 3. And now we got 2 logs being subtracted, so we rewrite this as a quotient, x to the 4th over 3rd root of x plus 6, and this is a base 3. So that would be condensing it. Part B. Now there's a watch out here. It says the logarithm of a sum or difference does not equal the sum or difference of logarithms. For example, the natural log of x plus 4 does not equal the log of x plus the natural log of 4. That's a mistake that a lot of people make. So when we're condensing this problem, we take the coefficient, the 6, and we make it an exponent. Same thing with the 3. Now we're going to put these two guys together because when two logs are being added, we'd multiply. And so that's going to give us x to the third times x minus 4 to the sixth. Using brackets on that, or you could just use double parentheses. So again, over here, what I was saying is that the natural log of x plus 4 does not equal the natural log of x plus the natural log of 4. It's kind of like if you would think of it as the distributive property. You cannot distribute logs into parentheses. More on condensing. We'd take this problem, take the coefficients, and make them exponents. So we got x plus 1 to the negative 5 base 2. Added to the log of 6x cubed base 2. Now we got two logs being added, so we'll rewrite it as a product. So x plus 1 to the negative 5 times 6x cubed. This is a base 2. And that's okay for an answer. I would rewrite this because negative exponents we usually get rid of. So 6x to the third over x plus 1 to the positive 5 base 2 is the best way to write that. And so then we have another one with natural logs. So now this time, let's take those coefficients and make them exponents. First term stays unchanged. The next term becomes the natural log of x to the fourth. And then last term stays the same, x minus 1. Well, this is similar to two problems earlier that I just did. We've got two logs being subtracted, so both of those are going to end up going on the bottom of a fraction. We got 3x plus 5 for our numerator. We're going to have x to the fourth and x minus 1 in my denominator, and this is a natural log. So I'm going to put parentheses around that. That would be the condensed form of that expression. So expanding and condensing, we got problems 19 through 26, all, and then 29 through 47, odd, and this will be collected Monday along with the 1 through 16 I gave you on part 1.